Okay, today we want to continue learning how to solder surface mount devices. And this is the package that we got. It's a very inexpensive kit to learn SMD soldering, which includes also different kinds of integrated circuits in small packages and SMD, resistors and capacitors. So if you always wanted to learn how to do this stuff, this is an inexpensive way to try out things without breaking expensive equipment. So yeah, let's see what this can actually do. SMD stands for surface mount devices, which is in contrast to other soldering jobs where you have through-hole devices such as these tiny little capacitors. They have legs and they go through holes, that's why it's called through-hole. But that's actually a bit inefficient for automatic soldering and automatic assembly, because robots are very good at picking up things and placing things, but mainly if those things don't have any like long legs or something, but rather little square pieces like these little capacitors here. So these two things are actually equivalent, but these are SMD capacitors and these are through-hole capacitors. Yeah, and as a machine that's easy to solder, for human it's not quite as easy, which is why we try to do that today. These here are little transistors, tiny little transistors, and we have a couple of chips here. The packaging have different formats. These big square ones are called QFP44 because they have 44 pins. And yeah, we will solder those probably first. And we have some SO style packages here, which we will also solder first. Probably we start with the SO packages because those are the easiest. What do we need for that? We need a proper soldering iron. I will link to my stuff in the video description, but you can choose any kind you like, but this one works well for me. This is leaded solder, which is not really allowed anymore in the European Union, but is easier for beginners. It's easier to work with than the non-leaded solder. So I'll take this one. And I still have a little bit of stuff left before I have to switch to the lead-free one. Also very useful is stuff like this. This is called flux paste. The solder that I'm using also already contains flux, but especially when you're doing SMD stuff, you want to have more flux. You can never have enough flux. The flux makes sure that the solder only goes where it's supposed to go, and it will evaporate when heated. So yeah, make sure to have something like this. I'm using this one here by Emil Otto. It's the German company. You can use any kind of flux paste. I like this one because it's similar to the rosin-based flux. It smells not as terrible and it's not as aggressive as some of the halogen-based flux. Okay, so what I'm going to do now is I will take my iron, which is heated to 350 degrees Celsius, and dip it onto the solder and wipe down the SO pads with a little bit of solder. This is called pre-tinning, and this will let us solder the ICs more easily. And you can already see that after the first run of solder it creates bridges, which is not very nice. And to avoid this, we will put some of the flux on there. And when we do that, the solder will actually flow to the pads. Okay, so here is the end result of the two SO packages after tinning. So we have applied fresh solder onto them. There's quite a bit of flux there now, which is fine. We can clean it off with some isopropyl alcohol later. We can scrub down the board to make it clean and nice and shiny. But for now, that's good. The flux is also helping when we place the ICs. You will hopefully notice that there is a notch here at the chip, at this top end of the chip, and here as well. And the chip, of course, also has a notch or a dot where the top of the chip is. So when we place this down now, we'll have to make sure to place it correctly, because in the end this will do something. I'm not sure what it will do. Yeah, we will place the ICs here and then solder 2 legs at the opposite ends to make sure that the chip doesn't slide around. And then we'll just heat up every leg individually and attach it permanently to the board. Okay, with a little bit of trickery, we got the second SO chip on there as well. And I'm wondering if there's actually any useful output on this. I think these pins up here might be outputs, but there are no LEDs in the kit, I think, which is a shame. The last one did have LEDs. We have the transistors, we have regular diodes, but no LEDs. But maybe we can measure what's coming out of this one here, because those are probably some microprocessors or something here. Whoops, one of them is falling down. What does it say? It says TM1621B. Yeah, we will have to look that up. Anyway, we will solder now these little buggers, which will work in exactly the same way as the SO package. It will be a bit harder because the spacing between the pads is smaller. But we will pre-tin the pads, apply some flux to make it more even and to help with the soldering after that. And then we will take down one pin on one side, then one on the other, and then either wipe down all the pins and make sure that there are no solder bridges. But we'll have a look after that. So now I'm gonna tin the pads for one chip and apply some flux. So, some people might be wondering, what is the board actually made of and how does it work? How does the solder stick to it and everything? So, the board itself, usually, and so there are different variants, but usually it's made of fiberglass. And the green stuff that you see on the back and on the front is so-called solder stop. It's a material that repels the solder, so the metal here, so that it doesn't stick to it. The fiberglass is actually coated, this one is only coated on one side with copper, so the orange metal that you probably know. And then a photographic process is used to etch away parts of the copper, so that only maybe you can see that the small traces of the circuit, the actual circuit, remains. All the other copper is being washed away and can be recycled. The parts where there shouldn't be any solder sticking to it will be coated with the green stuff, and the other parts, the copper will be exposed. Because copper will corrode and get greenish, it will be covered with some other metal. In this case, it's some silvery, shiny thing. I'm not sure what it is. Might be tin-based or something. And in more expensive boards, it will be coated with gold, because gold won't tarnish. And the leaded solder or the non-leaded solder can stick to either of those metals. So when I'm going with the solder and the soldering iron over the pads, my leaded solder will stick to the metal pads and make a little bit of a bump that can be melted with the soldering iron and attached to the legs of the chips or other components. And that's how this whole thing actually holds together. So looking at these two packages for the chips and the footprints, there is a very tiny white triangle up here in the corner. That denotes where pin 1 is of the chip. And the chip always has like a little bump over here, which also denotes pin 1. So we need to align the triangle to the bump, which is in this corner for both packages. So for the chips, it always is important which direction they are facing. For the capacitors, the resistors, it doesn't matter. For the transistors, it does matter, but they have 3 legs, so you can't put them in the wrong way. And for diodes, it also makes sense, which is why there's a little bar here showing where the bar should be on the diode, but we'll come to that later. So some components have a direction, some don't. So the second chip is a bit crooked, as you can see, but I think we are fine. There's a little bit of tolerance that you can have. Still not sure what they're doing. I have to really look up the datasheet. I'm gonna tin now all the pads for all the resistors, diodes, etc., because we will have to solder them anyway, and this is just one little boring task. So I'm gonna pre-tin all the pads, apply flux, and then we're gonna go and solder all the resistors and the other stuff. And those are similar to the kit from the last video. There are test points. We can use our multimeter to probe that, and we should see connectivity and some sensible values. If you did something wrong, you will see no connectivity over those two test points. Same goes for this one, and for the capacitors as well. Again, I don't have a multimeter that can measure capacitance, but we can probably, see something there, or just think that it's all right. But for the resistors, we can at least see something. Same goes for the diodes. We should be able to measure the voltage across the diodes, so that's also fine. So, next up, tinning and more flux. Okay, now I've got a very, very sticky PCB because it's full of flux, which is a good thing, but my hands are sticky too. And now we can populate all the other components, and I think for simplicity's sake I will start with all the resistors over here, which are packaged in these things. And you can tell the resistors from the capacitors. I mean, they look more or less the same, but the resistors always have a very small number printed on them, which is their value, and they are black and have the silver sides, and the capacitors usually are brown or white, and they don't have any number on them. Usually if you buy components yourself, you will know what they are because it will be printed on the bag that they come in or something. And these actually, as you can see, SMD components are for machine placement. They come from a reel, like a big spool, and the machine will feed this part in, and the holes will be used for transporting the strip. They will peel off the top foil and take one of the components and place it, and then the next, and so on, with the little robot arm. We will have to do that ourselves, and we use some tweezers for doing that. Or your fingernails for peeling off that stuff. Make sure not to throw them all away, because they're very small, and these are even still the bigger ones. And I will just pour them out on my mat here. The resistors are from one side white and from the other side black. It actually doesn't matter which way you place them. But let me try to show you one on my hand here, if that's possible. Yeah, you can probably see it. So there's the black square with the silver sides. And the silver sides, of course, have to go on the pads because those are what the solder will attach to. So I'm gonna zoom in a little so that you can actually see a bit more. I will, for testing purposes, I will place one of them down here. Use another tool because the solder is very sticky, to remove it. So now I've placed it roughly in the correct spot. I will push gently down with some kind of tool and heat up one side. And then suddenly the solder solidifies, and I've got a very crooked looking resistor. You can see it stands sort of upright. I will correct that in a second. This is called tombstoning because it looks like a little tombstone somehow. We have to correct that. We have to heat up that pad again very gently and push on the other side of the resistor. And then we flip it around, heat up the other side while pushing down gently, and then we will hopefully get the resistor to align itself. You can alternate from one pad to the other and heat it quite nicely while the solder is still fluid, basically not solid anymore. And when you do that once or twice, you will actually get a pretty decent result. The resistor is nice and flush, as you can see here. And you soldered your first SMD resistor, which is actually pretty tiny. And we have to do this a couple of times now. If you have a hot air station, you can simply place all the resistors on there and blast the whole thing with hot air, which is actually what the machines would be doing. But we are trying to learn hand soldering here, because you might just want to replace one broken transistor or resistor on a broken piece of equipment, and then you sometimes can't do that and you have to use the iron. So I'm gonna place all of these, but I will spare you the wait for that. So see you in a minute. Okay, we have put down all the resistors and the capacitors. All the resistors? No, not all of them, but the big ones in quotation marks. Up here are smaller sizes, the 06, 03, that's actually the size. 08, 05 is the bigger size, same as here for the resistors. 06, 03 is, well, tiny, as you can see. And they are absolutely tiny. I think I can capture this. So they are a bit even more tricky to put down and tack down than the bigger ones. So be extra careful how you handle them. But they can take quite a beating, so yeah, you can heat them up pretty good and they will flow into place almost like magic if you have enough flux. And you can see here the shiny flux is there. So I'm gonna put down all the little resistors and then we will deal with the transistors. Okay, we have put down the 06, 03 sized resistors, and now we want to tackle the transistors. Transistors, as you know, are little electronic switches, or they can also be used for amplifying. And they are here in this package, and they have 3 legs, the base, the collector, and the emitter. So you really can't put them on in the wrong way, because they are sort of, yeah, 2 pins at one end, 1 at the other. You have to be a little bit more careful with these. They are a bit, well, heat and electricity sensitive, but I think one quick solder job won't harm them. And I'm not even sure they are connected, but I'm not even sure how to test them, which goes for the whole board. I will definitely have to crack out the translation app for this one to see how to test it. I think there are pads over here and pads over there. We probably put some power in some of them and then we will get something out, hopefully. Yeah, okay, let's start the transistor soldering. The transistors are done, and they were rather easy. When you alternate between the top and the bottom side and heat them up quite evenly, they will pull themselves on the pad without much hassle. We will now do the diodes, and if we are as lucky as with the last kit, they will fit very, very tightly onto these, and they will be not very nice to solder. And the last ones will be the resistor networks that are here. Those are, I guess, probably 4 or 7 resistors in one package. Not sure how they are wired. Probably with one common ground, then it should be 7 resistors in one package. And they are pretty tiny, so I leave them for last. But first the diodes. Those are actually also rather heat sensitive. With the last kit I destroyed one. Let's hope we don't do that today. And I wish they would leave a bit more spacing for the pads, because then the soldering would be better. A hot air gun would be perfect for these, but we don't have that, so we will try and make do with the iron. One more thing regarding the diodes, and they have polarity, and they have, maybe you can see that here, a black bar, and you have to align the black bar with the white bar, and they didn't mark it very nicely, but they look like open or closing brackets. So make sure to have the black bar on the side where the bracket faces, basically. Otherwise, you will not destroy them when probing, but you will get weird results. So make sure to put them in properly. Since we are done now, we can clean up the mess on this, and we will have a closer look on all the different solder joints that we made. By now I have translated what it says right up here, and it says basically this is for a speed soldering competition or something, and the chips here are actually LCD drivers. So I probably won't be able to test that. I guess for the competition there would be a testing rig that attaches here and here. And if you solder it correctly, it will show something on an LCD, probably. And I also did a small mistake. Those resistors here were actually different, as you can probably see. Let's zoom in a bit. These are different from these. These are basically 0 ohm resistors. Which are basically jumpers, SMD jumpers, and those should have been placed here, I think, because these are in series, and the 10 that I have here should have been placed here, because these are all in parallel, mostly. So when I measured here, I get a short to ground, which isn't that perfect, but we'll have a closer look afterwards. First, you will need some anti-static brush. Those are very cheap, like a bag of a couple costs 2 or 3 euros. I use some porcelain dish, and you need isopropyl alcohol, which is flammable. This one here is, I think, 99% or something, very high grade from a pharmacy. They are not very expensive. A liter costs something like 8 euros tops, and it lasts me for quite a long time. I need probably 1 bottle per year, something like that, so it's not that big a deal. So I pour something in here, and this is already very generous, and then I just wipe down everything very thoroughly. The rosin flux, even the synthetic rosin flux, will dissolve in IPA. You can use less and a smaller dish, or you can clean up multiple boards. After a little bit of time, this will be discolored. You can probably see that already here by the rosin flux. So you might have to change the IPA in the dish sometimes. But for our purposes, this is good enough, and will help us inspect the solder joints better. And yeah, you don't necessarily have to clean the flux off. If it's non-conductive flux, like the Rosen flux, it's called no clean flux. You don't have to do that. But I use so much flux that it's actually very sticky, and it's nicer to have a clean PCB, especially if we want to take a look at it. Afterwards, you have to dry it. Just put it on a piece of paper towel. Be careful not to light any flames here, because this is, of course, highly flammable. Open the window maybe, because the fumes are also a bit, well, I'm probably not poisonous, but not the nicest thing, because it's purely alcohol. So I wouldn't drink it. I wouldn't want to inhale it. Yeah, but it's also not that bad. It's basically, at the moment, it's sometimes hard to come by, because you can make hand disinfectant from this, and due to the pandemic, it's obviously a very popular product. But this time I won't be disinfecting my hands with this stuff. Well, I am, sort of unintentionally. Yeah, I think this almost looks good. Let's wipe this down once more, and then I think we're good to go. I will leave this to dry, and in a few minutes we'll have a look. Okay, everything is dried and nicely and clean, or mostly dried. There's a bit of flux residue still, but for our purposes that's good enough for now. Let's inspect the whole thing here from the side maybe. Let's try to focus on this. I think you can see that the capacitors actually look quite nicely. Most of them are pretty straight. This one is a bit crooked, but the joints look mostly nice and shiny. This here I think is still a bit of flux residue. Let's have a look at the SO chip. The legs look fine. There's no bridging to be seen on this side as well. I think here I didn't align it quite properly, but it's connecting to the pad. This one here is a bit crooked, but also still connecting to the pad well. The legs have this relatively nice shape. I think there's still a bit of flux under the legs, so a bit more washing might be appropriate. The solder joint here is a bit too thick, I would say. On this side it's a bit too thin. You could always touch it up. The diode here is a bit crooked. I measured the diodes here and they connect all fine. You can just use a multimeter on those probe points and put it into diode mode. For example, these are the resistor networks. They have 4 resistors each, and they are put in series. There's still some gunk from the flux. You can measure them with the 4 pads here and the 4 pads there. They also measured fine. As I said, these I misplaced, so I get a short to ground, but I can measure each resistor individually. The transistors, well, we have to believe that they would work, because I don't think that I can drive them without the testing rig. So that was actually nice with the other SMD kit, because you had a functioning circuit all on its own. Let's try to focus. Okay, here we go, slowly. Interesting part would be, I think I can't go any closer with this camera. The QFP socket here, or the QFP package, also looks pretty okay. I don't like these very much. I think there are no solder bridges. It's hard to tell from here. Maybe I'll crack out the USB microscope. I have a very cheap USB microscope, and maybe we can see something more. This one leg over here, it's not as nicely soldered as the other ones, but it probably still makes a connection. But this would be maybe candidate for retouching or reflowing. And I think there's a little bit too little solder on that one. You have to be careful that you don't do any solder bridges. If that happens, put on more flux and wipe down with a chisel once more. And yeah, it should reflow properly. There can also be solder bridges below the legs between the IC package, but the flux should drive everything out. So all in all, I think this turned out pretty well. I do like the other kit better, although it doesn't have the QFP packages, so you can't practice that. It would be nice to have something here that drives some LEDs or something that you can then test right away. But still, it's a nice practice board. It's very inexpensive, and which is what we have come for here, actually. And that's about it. I will link to search terms on eBay for these things so you can try it out yourself. And I'm very glad that you watched it. If you haven't, please consider subscribing, like the video if you found it useful. Definitely leave a comment on your experiences with soldering, especially SMD parts. And yeah, I hope to see you next time. If you want to, you can also support me on Patreon. Links are down in the description. Also Ko-Fi and PayPal are welcome. If you can't support me, that's also fine. Just click the like and leave a comment. That's it. I hope to see you in the next video. Until then, have a very nice evening.